Alright, so this is just a quick video to show you where the derivative of sine and cosine x come from. You're actually going to find the other four in class together. Yay! Okay, so we're going to use the original limit definition to prove these derivatives. So as h approaches 0, of sine of x plus h minus sine of x all over h. Okay, and to expand sine of x plus h, I'm going to use the actual sum identity for trig functions right here. Instead of alpha and beta, though, ours is x and h, so this would be an x, cosine h, cosine x, sine h. So let's plug that in real quick. Okay, so that would be sine x, cosine h, plus sine h cosine x, and then we still have our minus sine x on the end, all over h. Alright, so what I'm noticing here is I have two terms that have a sine x, this one and this one. So I'm going to rearrange it with those next to each other. So sine x cosine h, and then I'm going to bring that minus sine x next to it, and then put that plus sine h cosine x on the end, all over h. Okay. So now I'm actually going to break it apart into two limits. This is one limit, and this one kind of on its own. So sine x cosine h minus sine x all over h. And over here, that's going to become its own separate limit of sine h, cosine x. Alright, so, again, the reason that I broke these up is because these both had a sine x. So I'm going to factor that sine x out front, and that leaves me with, I do that all the time, cosine h minus 1 all over h. And then this one's just hanging out, not much happening. Okay, so now what I'm thinking is I'm looking at the limit as h approaches 0. So things with an x aren't really going to be affected by h approaching 0, so I can actually just pull them out front. So just to get them out of the way, I'm going to pull sine x out front, and that would leave me with the limit as h goes to 0 of cosine h minus 1 all over h plus, again, if it's going to x, not affected, so I'm going to pull that out front. And that leaves me with the limit as h goes to 0 of sine of h. You know what? I'm crazy. These were all supposed to be over h's. Oh, Miss Wright. Okay. Did I forget it? Yeah. So obviously when you break this apart, it's still over the denominator. That was a mistake. Sorry about that. Alright. Now what does this turn into? Well, we have seen these before. This whole thing, the limit as h approaches 0 of cosine h minus 1 over h, that equals 0. And the limit as h approaches 0 of sine h over h, that is 1. Those were our special trig identities from back in the limit unit. So this leaves me with sine x times 0 plus cosine x times 1. And guess what? That leaves me with cosine x times 1, which is cosine x. This is why the derivative of sine x is just cosine x. Woohoo! Okay, so it's going to be very similar for cosine. So using our limit definitions, I'm not going to make that same mistake though. I'm going to get it right. Okay, so that would be cosine of x plus h minus cosine x all over h. And you know where we're going with this. Now we're going to go down to cosine of x plus h, which looks like this, except again with x and h. So cosine x, cosine h minus sine x, sine h. Okay, and we're going to look where we can break these apart by looking for things that have a common factor. I'm seeing cosine x and cosine x. So I'm going to rearrange those. So cosine x, cosine h minus cosine x. And I'm going to go ahead and break it apart. This will be the other fraction. So that's all over h minus the limit as h approaches 0 of, actually, you know what, we'll make that a plus, and we'll leave this sign, negative sine x sine h. All over h this time. Won't forget that. Okay, so this has cosine x as something we can just factor out front. So limit as h goes to 0. We're going to factor out cosine x, and that's going to leave us with cosine h minus 1. This looks familiar. Okay, come over here. There's not really any factoring to do here. All over h. Okay. So now let's pull things out front that have just x's, right? We don't need those inside the limit. So I'll pull out my cosine x times the limit as h approaches 0 of cosine h minus 1 all over h, plus, over here I can pull out this minus sine x, and that leaves the limit as h approaches 0 of sine h over h. And now we've got our identities again, right? So this whole thing just becomes 0, and this whole thing just becomes 1. So I have cosine x times 0, and then plus negative, I'm just going to write as a minus sine x times 1. So of course that goes away, and we're left with negative sine x as the derivative of cosine x. Amazing. So we'll derive the last 4 trig identities in class, but I just think it's so cool how we figure these out. It's awesome. I hope you enjoyed as well.